You know, when you look up at the moon, you probably see what I see, a quiet, unchanging, maybe even a little bit boring ball of rock. But what if I told you that for centuries, people have been seeing something else entirely? A moon that's alive, it's dynamic, and it's flashing with these mysterious lights.
Now, that's not a line from some fantasy novel. That's a real account from a monk way back in the year 1178, trying to describe something absolutely astonishing he saw on the crescent moon. And believe me, he wasn't the last one.
For almost 1,000 years, reports just like that have been piling up, creating one of astronomy's most fascinating and long-lasting mysteries. So, what in the world is going on up there? Let's dig in and see if we can unravel this cosmic puzzle together.
Okay, so before we can start solving anything, we need to give these weird events a proper name. You know, something that takes them out of the realm of just strange stories and puts them squarely into the world of science. And that name is Transient Lunar Phenomena, or TLPs for short. The term was actually coined by the legendary British astronomer Sir Patrick Moore. This guy spent decades cataloging all these bizarre sightings, insisting that they were real events, not just, tricks of the eye or something.
All right, let's play detective for a minute and build our case file. The evidence for these things, for TLPs, isn't just one or two weird reports. Oh no, it's a whole pattern of observations that has gotten more and more convincing as our technology gets better. I mean, these clues stretch across centuries. In 1777, you have William Herschel, the guy who discovered Uranus, noting these strange bright points. Then bam, a huge leap forward in 1958. A Soviet astronomer, Nikolai Kozyrev, didn't just see one. He actually captured its light signature, its spectrum, and proved a cloud of carbon gas had just erupted from a crater. Then the Apollo missions confirmed it further, and today, people like amateur astronomer Daiichi Fuji are using high-speed cameras to get this stunning, undeniable video of these flashes. The evidence is it's overwhelming.
So, with all this modern evidence, a prime suspect has really started to emerge from all the different theories. It turns out, the most common explanation for these flashes is something both incredibly simple and incredibly violent. And this really gets to the heart of it, the massive difference between here on Earth and up on the moon. See, our thick atmosphere, it acts like a planetary shield. When space rocks hit it, they burn up, creating those beautiful streaks we call shooting stars. But the moon, it's got no protection at all. No air, no shield. Every single impact is a direct, full-force hit.
And we are talking about just incredible speeds. I mean, according to NASA, the fastest of these little meteoroids can slam into the moon at over 160,000 miles per hour. It's hard to even wrap your head around that. At that kind of velocity, even a tiny little rock packs an unbelievable punch.
So this is what happens in that split second. First, the impact. The meteoroid hits. All of that motion, that kinetic energy, is instantly converted into a massive burst of heat and light. And that is the flash we see from all the way back here on Earth. All that's left behind is a brand new crater on the moon.
Let's just take a look at one of Daiichi Fuji's recent captures to see this in action. The thing that hit the moon was tiny, estimated at just 0.2 kilograms. That's about the weight of a hamster, right? But it created a flash bright enough to be seen from Earth and blasted a new 3-meter crater. That is the kind of power we're talking about.
So how often does this happen? Well, way more than you'd think. These things were once considered super rare, but now, data from the European Space Agency suggests that across the entire moon, there are an average of 8 of these impact flashes every single hour. The moon is just constantly getting pummeled.
So that settles it, right? Case closed. It's just cosmic target practice. Well, maybe not. Because while impacts are definitely the prime suspect, they might not be working alone. Turns out the moon has other secrets buried deep inside.
And this is a really crucial point. Even with all this strong evidence for impacts, they just don't seem to explain all the sightings. Especially some of those old historical accounts that talk about reddish glows or weird hazes. The mystery, it seems, has another layer.
So scientists have these other really credible theories, sort of like accomplices to the crime. One idea is that pockets of gas, stuff left over from the moon's ancient volcanic days, can seep out through cracks. Another is that high-energy particles from the sun could be causing certain rocks to literally glow in the dark. But a really key accomplice might be seismic shaking.
Oh yeah, the moon has quakes. We call them lunimotos. But here's the wild part. Unlike earthquakes here, which are caused by our tectonic plates shifting, most moonquakes are actually caused by us. The massive gravitational pull of the Earth is constantly squeezing and stretching the moon, making its insides tremble.
Now, most of these lunimotos are tiny, less than a 2.0 on the Richter scale, you'd barely feel them. But about once a year, the moon can get hit with a quake as strong as a magnitude 5. Now that's powerful enough to crack the surface and maybe, just maybe, release some of those trapped gases, creating the exact kinds of strange glows that people have been reporting for centuries.
So we've got impacts, we've got moonquakes, we've got escaping gas. This is a fascinating mystery, for sure. But it's not just some academic puzzle. Figuring this out and monitoring these flashes has become really, really important for our future in space.
This is why agencies like NASA and the European Space Agency run these dedicated monitoring programs. By tracking the flashes, we can map out the space debris in our cosmic neighborhood. It's absolutely crucial for figuring out the risk to future astronauts and lunar bases. And it even helps us forecast meteor streams that could be a danger not just to the moon, but to us here on Earth.
And here's the really brilliant part of the whole thing. By watching for flashes on the dark, unlit part of the moon, scientists are basically using millions of square kilometers of lunar rock as a massive natural detector for incoming space rocks. It's just a genius way to track a threat that's otherwise really hard to see.
So, where does that leave us? Well, we've kind of landed on a powerful two-part conclusion. First, the main reason for most flashes is clear. It's a constant barrage of meteorite impacts. But, and this is a big but, we've also discovered that impacts don't explain everything. It turns out the moon is way more geologically active than we thought, with its own internal quakes and leaking gases.
And that's really the key takeaway here. Understanding both of these things, the threats from the outside and the stirrings on the inside, is absolutely vital if we're going to safely send people back to the moon. So the next time you look up, just remember that silent-looking disk isn't so quiet after all. It's a dynamic world of violent collisions and deep tremors, which just makes you wonder, right? What other secrets is it still waiting to reveal?